Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. I'm going to go through all of the stuff you need to know for your upcoming test. So 2 sections that you need to know, one being equations and one being graphing linear equations. So this video will just be about the equations part. So let's start. So the kind of equations we've looked at, yes, they've all been linear equations, and I'll explain in the other video that means they just are a straight line when you graph them. So they have one pronumeral, which of course means a letter. So there's one letter and there's one solution. And with any equation, it is an equation if it has an equal sign. So we looked at solving these equations. Now we looked at many different types of equations. They can look quite differently, but we approach them the same way. What we want to do is we want to undo everything that's been done to the pronumeral, and we want to find a solution. So let's look at a very simple example like x plus 2 equals 7. You can probably figure out the answer to this without too much effort. So this equation, like all the others we do, we have our pronumeral, and we want to find a number that we can substitute for that pronumeral to make this a true statement. Now obviously, if I substitute x here, I get rid of x and I change it to 5, then I get a true statement. 5 plus 2 equals 7 is a true statement. If I had chosen any other number, then it wouldn't have worked. 4 plus 2 does not equal 7. So 4 plus 2 equals 7 is an untrue statement. So that's why the solution to this was x equals 5. Okay, that was an easy one that you can do in your head. But we've gone through ones that require a few more steps. So if you have something like 3x minus 12 equals 48, for example, the process, the idea behind it is the same. We want to find a number that I can substitute for x to make this a true statement. Now, there are a couple of ways that you can do this. Both of them involve undoing everything that's been done to x. So the balance method, we undo what's been done to x in the opposite order to BODMAS. So instead of subtracting 12, we'd add first. Now we need to do this first because if I think, what have I done to x? I've times it by 3, and then I've subtracted 12 to get 48. So when you're undoing things, you have to do them in the opposite order. So I subtracted 12, last thing I did. So then when I'm solving, I have to undo that first. And of course I undo subtracting 12 by adding 12 to both sides. Now whatever you do to one side of the equation, you must do to the other. So if I add 12 to both sides, so negative 12 plus 12, they just cancel out, just equals 0, and I'm left with 3x equals 48 plus 12, which is of course 60. So I've got 3 times x equals 60, and of course I'm going to undo timesing by 3 by dividing by 3, and if I divide this side by 3, I must also divide the other side. So then I'm left with 3x divided by x is x, 60 divided by 3 is 20. My solution is x equals 20. I can easily check that. So to check it, I substitute x equals 20 into the original equation and see if I get a true statement. 3x minus 12 equals 48. So to check it, I'm going to take my x and I'm going to change it to 20. Of course, I have to do 3 times 20 because 3x means 3 times x. So I get 3 times 20 minus 12 equals 48. That is a true statement. So I know that I am right. So the other way you can do a question like this is using the flowchart method. So I'll now show you an example of that. So let's say I have this equation here, 7x plus 24 equals 3. So this is another 2-step equation because there are 2 things I've done to x. So the way I do a flowchart is I start with x and I tell the story of what I've done to x. So I've taken x, taken an unknown number, I've multiplied it by 7 to get 7x. Then I added 24 and somehow I ended up with 7x plus 24, but I also ended up with 3. So the way I solve the equation is I start with my answer 3 and I go the opposite way. So instead of adding 24, I subtract 24. So if you're having trouble with negative numbers, use your calculator. 3 minus 24 is negative 21. Instead of timesing by 7, I divide by 7. So the answer here is x equals minus 3. Again, I can check it by substituting into the equation 7 times negative 3 plus 24. If I put that on my calculator, I get 3. So this is a true statement, and I know my answer is correct. Now, please don't assume that the answer to an equation has to be a whole number, and don't assume that it has to be a positive number. It can be negative, can be a fraction or decimal. Okay, so let's look at some equations with division, with a fraction. So let's look at these two equations that look very similar. So let's say we have x over 4 minus 5 equals 12, and this, which look very similar. Now, the difference between these two, they only differ by one thing, and that is the order of operations. Because of that, we have to solve by doing things, undoing things in a different order. So for the first equation, I've taken x, an unknown number, I've divided by 4 and then subtracted 5 due to BODMAS. So when I'm solving, because the last thing I did was subtract 5, when I solve, I'm going to have to add 5 to each side first, because adding 5 undoes subtracting 5. But in this one here, I actually subtracted 5 first and then divided my answer by 4. So these two look similar, but because of order of operations, they're going to be different. I'm going to do things in different order, and I'm going to get a different solution. So to solve the first one, as I said, I'm going to need to add 5 to both sides of the equation. So then I didn't change this fraction at all. It stays exactly as it was. So x over 4 is 12 plus 5, which is 17. Now, this line here means divide. The way I undo dividing by something is timesing by it. So instead of dividing by 4, I times each side by 4, and I get x equals 17 times 4, which is 68. That is my solution. And you can check that again by substituting x for 68 and seeing if you get a true statement. So let's look at the second equation now. So here I subtracted 5, then divided by 4. So when I'm solving, I must times by 4 first. So if I times this left-hand side by 4, I must also times the other side by 4. Now, when you times a fraction by 4, you don't just times the top and the bottom. Timesing by 4 and dividing by 4 cancel out. So on the left-hand side, I'm just left with x minus 5. And on the right-hand side, 12 times 4 is 48. Okay? And now to solve from there is very easy. Saying what number do you subtract 5 to get 48? Well, of course, that number is 53. Okay? So now we'll look at some equations with brackets. Okay, so these two equations, again, look very similar. They differ only by order of operations. In the first one, I've times x by 2 first. In the second one, I've subtracted 9 from x first. So when I'm solving, I will undo things in a different order and get a different solution. So for the first one, I just add 9 to both sides. This is just like the equations I was doing before. So I get 2x equals 15 plus 9 is 24. Then I'm going to divide each side by 2, because that's how I undo timesing by 2, and I get x equals 12. Again, you can check that solution. The second equation, because I've subtracted 9 first, then multiplied by 2, I'm going to undo timesing by 2 first. And then I'm just left with x minus 9 equals 15 divided by 2, which is 7.5. Now I'm going to add 9 to both sides to undo subtracting 9. X equals 16.5. Okay, so we got totally different solution because the order of operations was different. Now what I wanted to show you is that this second equation where there are brackets, I can solve that by first expanding the brackets. Remember, you expand the brackets by using the distributive law. You take what's out of the brackets, you distribute it to everything inside the brackets. So 2 outside of x minus 9, I go 2 times x is 2x. 2 times 9 is 18. Positive times a negative gives a negative. So this is the same as 2x minus 18 equals 15. Now that I've expanded the brackets, it looks just like this equation up here. I know the numbers are slightly different, but I do it the same way. So instead of subtracting 18, I'm going to add 18. So I get 2x equals 33. And then, of course, to undo timesing by 2, I divide by 2. And I get x equals 16.5. Now, sometimes you will have to expand the brackets. You will not have a choice about it. I'm going to show you an example of that now. So let's say we have an equation like this. So there are brackets. Now, I have to expand the brackets. I can't do it the other way. And the reason that I have to expand the brackets is the pronumeral, x in this case, is in more than one spot. For any linear equation, if x is in more than one spot, you must get x to one spot before you can solve it, before we can use the techniques I told you about. The only way to get x to one spot here is by expanding the bracket. So first bracket, 3 times x, 3 times 4, positive times a negative gives a negative. So then there's still a plus sign. I carry that down. So 5 times 2 is 10. 5 times x is 5x. Positive times a negative gives a negative. And that equals negative 10. Now, when you have a situation like this, you've got numbers, x's all over the place, collect like terms. So 3x and 5x are like terms. So I can add them. So 3 minus 5, I'm just adding the coefficients here. 3 minus 5 is negative 2. So I get negative 2x. Negative 12 plus 10 is negative 2. This is my equation now. So I'm going to solve this just like I've been doing heaps. I'm going to add 2 to both sides. Because I've taken x, I've times by negative 2 and then subtracted 2. So I have to undo subtracting 2 first. So I will just get negative 2x equals negative 8, because negative 10 plus 2 is negative 8. So this number in front of x is not 2. The coefficient of x is negative 2. So I don't divide by 2. I need to divide each side by negative 2. So x will be negative 8 divided by negative 2, which is positive 4. And again, I can check by substituting for x in these 2 spots. So if I put in my calculator 3 times 4 minus 4 plus times 2 minus 4, I get 3 times, this is 0, plus 5 times negative 2. And that does equal negative 10. If I put this on my calculator, I will get negative 10. I have a true statement, so I know that my answer is correct. So remember, if x is in more than one spot, you need to first get it to one spot. Now we look at equations with pronumerals on both sides. So let's look at this equation here. So I've got an x on both sides of the equal sign. So as I just said, I need to get x to one spot. Now when x appears on both sides of the equation, or of course if I'm not using x, when a letter appears on both sides of the equation, you get it to one side by subtracting the letter with the lowest coefficient or number in front of. So here I've got a 3x and a 7x. So I'm going to subtract 3x because that's the one with the lowest number in front of. If I subtract 3x from this side of the equation, the left-hand side, I must also do it to the right-hand side. So left-hand side, 3x minus 3x is just 0. I'm left with just 5 on the left-hand side. 7x minus 3x is 4x. And I haven't done anything to the negative 10, so it stays as it is. Now you know how to solve this. We've done it a million times. We add 10 to both sides to undo subtracting 10. So I get 15 equals 4x. Now, I have 15 equals 4 times x, so I undo timesing by 4 by dividing by 4. I won't get a whole number this time. I'll get I'll show you. I'll get 3.75 equals x. Just wanted to make the point. That's exactly the same as saying x equals 3.75. Doesn't matter that the x is on the right-hand side of the equation now. So that is the solution. Now, if you have something like this, let's say 6 minus 2x equals 20 plus 2x. Okay? People freak out. They think, oh my god, a negative, what do? You do exactly what I just said. You subtract the x, in this case, with the lowest number in front of. So the lowest coefficient here is negative 2. Negative 2 is smaller than positive 2. But when you subtract negative 2x, that's the same as adding 2x. So I'm adding 2x to both sides in this case. So minus 2x plus 2x, they cancel each other out. I am left with this. So 2x plus 2x is 4x. Remember, 20, 2x, not like terms, can't add them together. So now I solve this equation exactly like I've done. I subtract 20 from both sides, so I get negative 14 equals 4x, and then I divide by 4 and get negative 3.5 equals x, okay? I want to show you one more complicated type of question where the pronumerals on both sides of the equation. So let's say we have an equation like this, where there's a fraction, but also there is a t on both sides of the equation. Again, it doesn't matter what they're called, the letter t, x, whatever. So our goal here is the same. We want to find a value we can substitute for t in both places, here and here, to make the statement true. So we can actually use the processes I was just going through, subtract the t with the lowest coefficient. So actually, this t here has a coefficient of 2 over 3, so it's the lowest one, and we could subtract 2t over 3 from both sides. But people tend not to like to deal with fractions, so they can be a bit harder. So what we can do instead as our first step, we can times by the denominator of the fraction, and then we will get rid of it, and it becomes just like a normal equation. So if I times this side by 3, I'll get rid of the denominator on the equation, but I also have to times this side by 3. Now you've got to be careful, because I have to times this and this by 3. I have to times everything on the right-hand side by 3. So 3 and 3 undo each other. I'm left with 2t minus 1 equals, so 5t times 3 is 15t. Negative 12 times 3 is negative 36, okay? So I'm going to solve this just using the processes I went through. Now I subtract the t with the lowest coefficient, so that's obviously 2t. So I'm left with minus 1 equals 13t, because 15t minus 2t is 13t, minus 36. I'm going to add 36 to both sides, because I want to undo subtracting 36. So I get 35 equals 13t, and t equals 35 divided by 13, or if you prefer mixed numbers, it will be 2 and 9 over 13. Okay, so that's just how you do it when you have a pronumeral on both sides and a fraction. So the last thing I need to go through is how to solve problems using equations. So whenever we're solving problems using an equation, always follow these 3 steps. So your first step is to define your variable. Let x, or whatever letter you want, be the thing that you're trying to find. Now sometimes you're trying to find more than one quantity, in which case you let x be the smallest quantity. That's for simplicity. So part 2, step 2, you rewrite all the words you're given into an equation. So you rewrite it just using mathematical symbols. And of course you need an equal sign in that as well to make it an equation. And thirdly, you just solve as normal. Let's look at a question. I'll start off with a simple question. So let's look at this question here. 5 is added to 4 times a number, and I get 37. What is the number? I know you can do this in your head, but I'll show you how to use these 3 steps anyway. So first step, let x be whatever we're trying to find. So we're trying to find the number. What is the number? So I'm going to let x equal the original number. So the second step, I'm going to take all of this information in red, and I'm going to write it into mathematical equation. So I want to have no words, only numbers and symbols. So 5 is added to 4 times the number, and that gives 37. So I've rewritten all of this much simpler. Now, the way I solve this is the way I'd solve any equation like this. Subtract 5 from both sides, divide by 4. So you get 4x equals 32, which means x equals 8. So, of course, the number is 8. So let's look at a slightly harder problem to solve. All right, so let's have a look at this question here. A team has won 12 more matches than it lost. If the team played 24 matches, how many wins and losses did they have? Now, you have to make sure that when we're defining a variable, we only define one variable. We can't have an equation that has 2 different letters or pronumerals in it, because then you have infinitely many solutions. So we don't want to have a different letter for wins and a different one for losses. I don't want to say wins plus losses equals 24. I really don't want to do that, because there are 2 letters. It won't work. I need to have one letter. So what I said before is when there's more than one quantity, here there's two quantities, number of wins, number of losses, let X or whatever number you want, be the smaller quantity. So here, I am talking about a team that won more matches than it lost. So I'll let X equal the number of losses, okay? If we let X be the smaller quantity, it just allows the numbers to be a bit easier. So if X equals the number of losses, the number of wins, I don't want to call it Y or W, I want to write it in terms of X. So this team won 12 more matches than they lost. So if X is the number of losses, X plus 12 equals the number of wins. So now I've defined my two quantities, I can write my equation. Number of wins plus number of losses, which is 12 fewer, equals 24. So wins plus losses equals 24. I've rewritten this information into an equation. So of course, as I said previously, if X is in more than one spot, you need to get it to one spot. So X plus X is 2X. So 2X plus 12 equals 24. That's my equation. So if I go through and solve that, I subtract 12 from both sides and divide by 2, I get X equals 6. So X was the number of losses. So that means there have been 6 losses and the number of wins is 12 more, so 18 wins. So that is how I answer the question. 24 matches, won 18, lost 6. All right, I'm now going to do one more question that's quite a bit harder, involving solving problems. All right, so finally we'll try this question here. So Larry's perfume company pays its employees according to one of two options. You can either earn $300 a week plus get 3.5% of all the sales you've made, or earn $450 a week plus earn 2.9% of all sales that you've made. And I want to know how much money in sales I must make, so I earn the same for both options. I'm going to start off by doing the same that I've done in all the other worded questions. I'm going to let X equal the thing I'm trying to find, which is the amount in sales that I make, so that they're even. Okay, so X is going to be the amount in sales. Now I want to turn this into an equation. So hopefully what you can see is that through the question that I've given, some of the information is extraneous. It's not actually needed. For example, it doesn't matter whether this is a perfume company or whatever. The maths doesn't care. It doesn't matter whether it's Macca's, whatever. So the first sentence isn't really that helpful. So what I want to do is take the information that is helpful and turn it into an equation. So option 1, 300 plus 3.5% of the sales I make. I want that to give me the same amount of money as if I earn 450 plus 2.9% of the sales I make, which is X, okay? Now I don't want words in here like of, I don't want percent symbols, so I've got to just rewrite this a little. So 300 plus the 3.5% is 0.035. Okay, I've just changed the percent into a decimal, and of means times. So that is equal to 450 plus 0.029x. Now that I've got the equation, the hard part is done. So I want to subtract the x with the lowest coefficient, and that's this. 0.029 is less than 0.035. So I'm going to subtract that from both sides. And it's exactly the same as if I was subtracting x's with whole numbers in front of them. I just subtract the coefficient. So 0.035 minus 0.029 is equal to 0.006. So we have 0.006x. We still have our 300 here like normal and our 450 on the other side. So the way we solve this is the way we've done the rest of the question. So we're going to subtract 300 from both sides. And this number in front, 0.006, we don't treat it any different because it's not a whole number. 0.006 times x, we're going to undo that by dividing. So we put in our calculator 150 divided 0.006. So the answer I get there is 25,000. So what I'm saying is that if I sell $25,000 worth of stuff, I will earn the same amount of money as either of these options. Now I can check my answer again. I can always check my answer in maths equations, which is awesome. So all I have to do is put on my calculator 300 plus 3.5%, or 3.5 over 100 times 25,000, because that's what I'm saying is the amount at which I earn the same from either option. If I put that on my calculator, I get 1175. And I'll try putting the other one on my calculator. So if I put 450 plus 2.9% of 25,000, I also get 1175. So I know my answer is correct. All right, I'm just going to do one summary slide now. So for the test, make sure you can do all this for the equations bit. There is also the linear relations bit, but make sure you can do all of what's on the screen. Now, there are specific things you need to do for each of these. So for example, equations with pronumerals on both sides of the equal sign. There's a special thing you have to do, and that is, get x to one side of the equation first. But when you're doing all of this, the process is the same. Once you've got the equation, you undo everything you've done to the letter until you've come up with a number that you can substitute for the letter or pronumeral that makes the statement true. Remember, if x is, or any letter is, in more than one spot, you must first get it so it is in one spot so that you can do what I just said, undo everything that's been done to it. And of course, equations to solve problems, I went through the steps in a previous slide, so please make sure you know those. All right, this has been the luckiest maths teacher in the world. Have a great day.